hopefully be a review for you, so it shouldn't be anything new. The more important slides are the autonomic nervous system lecture slides, and so and you can get into those. So so after class, I'll get the intro slides posted back up. The link broke for some reason, so yeah, it's really weird. The links actually have a date when they time out, and if we don't go in, we have to go in each individual link and hit don't time out, don't expire, and then sometimes when we link something else to it, it then resets everything to expire, and it's just really weird.
These are all the same slides from last year and the year before.
Yeah, but they expire. So, or if we update something or change something, and then you have to go back in and get rid of the expired dates again. And so obviously the expiration date must have got not put back in, and this one got expired. So I'll fix that after class. So abdomen, pelvis, and thorax. This should sound somewhat familiar. This is to just talk about the ventral body cavity and the serous membranes associated with it. So everybody should remember, hopefully, this picture, and we had already talked about what's known sometimes in some textbooks as the dorsal body cavity, which contained the cranial cavity and the vertebral or spinal cavity. We talked about that in the last unit. We're going to go into what's now known in all textbooks as the ventral body cavity. Ventral body cavity is going to house internal organs known as the viscera. We talked about that before. And we know that located within that ventral body cavity is the skeletal muscle known as the diaphragm. That diaphragm is going to divide that ventral body cavity superiorly into the thorax and inferiorly into the abdominal pelvic cavity. We can do further divisions then from that point, looking at the thoracic cavity that can be divided into two pleural cavities, which are found laterally. Each one houses a lung. And then along the midline, we have what's called the mediastinum. And that mediastinum has a lot of different spaces associated with it, such as the superior mediastinum, but also the pericardial cavity. And that pericardial cavity is going to house the heart. Inferior to the diaphragm, then we have the abdominal pelvic cavity, and the abdominal pelvic cavity can be divided into the abdominal cavity and then the pelvic cavity. So this, if you like it more in a chart form, this reminds you of that information. So we've already looked at the dorsal body cavity. We're looking at the blue and green here. This is what's all in the ventral body cavity, which can be divided by the diaphragm into the thoracic cavity and the abdominal pelvic cavity. Abdominal pelvic cavity divided into the abdominal cavity and the pelvic cavity. You can see the context associated with it there. And then with the thoracic cavity, you have the two pleural cavities, and then centrally you have the mediastinum. Now they did an error in the fact that they said the pericardial cavity was separate from the mediastinum. It's not. Pericardial cavity is part of the mediastinum, and so make sure you're aware of that. And if you like flow charts, this does the exact same thing as well, and it shows you the different divisions and subdivisions associated with it. The other part that should hopefully be a familiar sounding information to you is the fact that these ventral body cavity, the different spaces associated with them, and the organs located within have what's associated with them is what's known as serous membranes. Remember, serous membranes, those are epithelial membranes that have some loose connective tissue, and then remember what the epithelium is associated with serous membranes? Starts with an M.
Mesothelium.
Mesothelium. So it's mesothelium with a little bit of loose connective tissue underneath, and we can histologically it's the same, it's just where is it located. If it's along the wall, it's called the parietal layer. If it's on the surface of the organ, it's called the visceral layer. So that means it sort of reflects back. It goes from the surface of the organ and then reflects back to the wall. When it's on the organ, it's known as the visceral layer. When it's on the surface of the wall, it's the parietal layer. And then this mesothelium is going to produce a little bit of what's called serous fluid. And it's because what you'll see is everything is really jam-packed into the ventral body cavity. But you know, for a lot of these organs, for them to do their job effectively and efficiently, they're going to have to be able to move. Lungs, heart, digestive tract, things are going to have to move to be able to do their job. And so they need to be able to slide past other organs and along the wall, and so this fluid allows them, it's sort of a little viscous fluid, it allows things to slide and not adhere to one another. That parietal layer and visceral layer then gets special names depending on what space it's in, and then so we know we have the parietal pleura and the visceral pleura, that's associated with the pleural cavities and the lung surfaces. And the way to kind of think about this is like a fist into a balloon. Think of your fist as your organ, And so along the surface, there's the rubber of the balloon, and so then it's going to reflect back, and then it's along the surface of the wall. So this would be known as the visceral layer, where it reflects back is the parietal layer. Structurally, it's exactly the same, it's just where is it located. And so if we're looking at the lungs, along the surface of the lungs, so if I handed you one of the lungs, what you're touching on the outside is going to be the visceral pleura, and then where it reflects back at the hilum where things enter and exit the organ, so reflect back along the wall, and then once along the wall, then it's the parietal pleura. And then the space in between is that pleural space, and that's where you find that serous fluid. You also then have the pericardial cavity, and so if it's along the wall of the pericardium, or pericardial cavity, it's the parietal. If it's along the surface of the heart, it's the visceral. So we see here the heart is sitting within the pericardial cavity, within the mediastinum, within the thorax, within the ventral body cavity. For along the surface of the heart, this is going to be the visceral pericardium where it reflects back. Then it's the parietal pericardium, and then we have a little space in between where we have fluid, that serous fluid. And we can see that here as well. Finally, we have the parietal peritoneum and the visceral peritoneum. This is dealing with the abdominopelvic cavity. Parietal peritoneum is along the wall. Visceral peritoneum is going to be on the surface of the organ. And so if we see here, here's the liver, for example. So if we're along the surface of the liver, this is going to be the visceral peritoneum, where it then reflects back and is along the surface of the wall. This will be the parietal peritoneum. Stomach, same idea. So if I handed you stomach, what's on the outside is that visceral peritoneum, and then along the wall, it's going to be the parietal peritoneum. So I just bring that up because we are going to be talking about the ventral body cavity, and so we're going to be talking about a lot of these organs, and so just keep that in mind as we talk about the different organs and the organ systems associated with the ventral body cavity. Any questions? So what we're going to do now is go back, and if you are going through the guidebook, you'll notice that we kind of skipped over a lot of the information in the autonomic nervous system lesson. We're going back to pick that up now because the autonomic nervous system is going to be important for innervating a lot of these organs that we're going to be talking about in the ventral body cavity. And a lot of these structures of the autonomic nervous system are found in that area. These are the different objectives and questions to keep in mind as you go through the content. And remember, the autonomic nervous system is part of the motor division of the peripheral nervous system. So remember, we have the central nervous system, which is your brain and your spinal cord. Peripheral nervous system is everything in the nervous system that's outside of the brain and spinal cord. It has the sensory division, which brings in information from stimuli, and then a motor division, which is going to then allow the body to relate to those stimuli by impacting them if needed. And so the motor division then has the somatic nervous system and the autonomic nervous system. The somatic nervous system is going to be what is going to be controlling skeletal muscle, while the autonomic nervous system also is impacting what are known as effectors. It's not skeletal muscle, but now with the autonomic nervous system, we're going to impact smooth muscle, cardiac muscle, and glands. So motor division is going to impact effectors. The effectors for the somatic nervous system is going to be skeletal muscle. For the autonomic nervous system, it's going to be smooth muscle, cardiac muscle, and glands. When we look at the autonomic nervous system, we're going to see there's two divisions, the sympathetic division and the parasympathetic division. Your sympathetic division is your fight or flight division. It's the one that kicks in if you're walking across campus, bear jumps out in front of you. It's the one that allows you to stand up and fight that bear or run like heck the other direction. Or you also have this parasympathetic division, which is the one that's in charge most of the time. It's known as the housekeeping division or the rest and digestive system. It allows you to do sort of the housekeeping maintenance activities for the body. Most of that smooth muscle, most of that cardiac muscle, and most of those glands are getting dual innervation from these two systems. It's just one of these systems is going to activate it or stimulate it, so turn it on, while the other one is going to inhibit it, so turn it down. So the nice thing about that is it allows for very fine control of that smooth muscle, cardiac muscle, and glands. Mm-hmm.
So for the sympathetic division,
Mm-hmm. does not. So the sympathetic division, the autonomic nervous system, is going to be part of the autonomic nervous system, which is going to impact your smooth muscle, your cardiac muscle, and your glands. Yeah. Fight or flight. Now it can do other things that are going to impact how that skeletal muscle reacts. So it can put adrenaline into the system, which can tune things up for the somatic nervous system. But it cannot directly impact and turn on the skeletal muscle. Yep. Other questions? So let's compare these two parts of the motor division a little bit further. And so when we look at these effector systems, we're going to see that obviously this is motor output from the central nervous system that then is going to impact something. And what we're going to be impacting are our effectors. For the somatic nervous system, it's going to be skeletal muscle. For the autonomic nervous system, it's going to be smooth muscle, cardiac muscle, and glands. And so this is a pathway from the central nervous system out to these effectors. And if we look at the somatic nervous system, it's a one neuron pathway. So somewhere in the central nervous system, you have a cell body of a motor neuron, and it's going to send its axon all the way out to that skeletal muscle to activate it. So it's a one neuron pathway or system to be able to impact that skeletal muscle. The autonomic nervous system is a little bit different. It's a two neuron pathway. So somewhere in the central nervous system is the cell body of that first neuron, and that first neuron is going to send its axon out to a second neuron, activate that second neuron, and that second neuron is going to go all the way out, then the rest of the way to that smooth muscle, cardiac muscle, or the gland. So it's a two neuron pathway. So that means the first neuron is going to synapse on the second neuron. So the first neuron is known as the presynaptic neuron. The second one is known as the postsynaptic neuron. But also remember that a collection of neuronal cell bodies out in the peripheral nervous system is known as a ganglion. So the first one is actually synapsing on the second one in a ganglion. So you can also call that first neuron the preganglionic neuron because it's going to be heading towards that ganglion. And the second one is the postganglionic neuron because it's going to be sending its axon away from that ganglion. So you can use either one of those terms for the neurons in that pathway. We also see that the neurotransmitters are different. In the somatic nervous system, we always see that one motor neuron that's sending its axon all the way out to that skeletal muscle is always going to release acetylcholine onto that skeletal muscle that causes that skeletal muscle to contract. So it's always excitatory. Now with the autonomic nervous system, we see that the first neuron, whether it's the sympathetic or parasympathetic division, is always releasing acetylcholine. And so it's going to activate the second neuron in the pathway. But remember that same smooth muscle, cardiac muscle, or gland that you have at the end has to get dual innervation. So somehow it has to know, hey, that bear jumped down in front of me, I need to be able to do this. Or no, we're doing housekeeping activities, this one's in charge. So the second neuron in the pathway is going to be releasing a different neurotransmitter, whether you're looking at the sympathetic or parasympathetic division. The sympathetic division, we're going to see that second neuron in the system is releasing norepinephrine. It could be excitatory to that cell or it could be inhibitory to that cell. It depends if that cell's needed in that particular situation. The parasympathetic division is always releasing acetylcholine. And again, it could be that it's going to be inhibiting that cell, or it could be exciting that cell. So when you look at that smooth muscle, cardiac muscle, or gland at the very end, it's going to be really getting norepinephrine from the sympathetic division. It's going to be getting acetylcholine from the parasympathetic division. It's just one of them is releasing more than the other one. Whoever's releasing more of its neurotransmitter is the one that's in charge. But it gives it very fine control then of that smooth muscle, cardiac muscle, or gland. Yeah.
So maybe I'm just confused somewhere, but I thought the general motor tracts were two neuron systems, like upper motor neuron.
That's within the central nervous system. So we're talking about going away from the central nervous system. So if you actually leave the central nervous system, it's only one neuron. It's going to have its cell body in say if it's coming from a spinal nerve, it'll have it in the ventral root in the ventral horn, and then it'll send its axon all the way out to that skeletal muscle. So sometimes those motor neurons have really short axons, and sometimes they have really long ones. With the autonomic nervous system, there's other neurons in the brain and spinal cord that are going to be impacting it, but once you leave the brain and spinal cord, it's 2 neurons that get all the way out to that effector cell.
Gotcha.
So it's how many neurons that it takes to get out within the peripheral nervous system.
Thanks.
Yeah. So the next couple slides just bring home that information. It just shows in a different form and in graphic form. Right now we're going to ignore this piece. We'll come back to that in a minute. So we're going to see that the somatic nervous system versus the autonomic nervous system, which we see here. Somatic nervous system, we see that in the central nervous system, we have the cell body of our motor neuron, and it's going to send its axon all the way out to skeletal muscle, which is its effector organ. In the sympathetic and parasympathetic division, you can see it's a 2-neuron pathway, 1, 2, to get all the way out to its effector cells, which are going to be your smooth muscle, cardiac muscle, and your glands. So 1 neuron pathway, 2 neuron pathway, here are your effector organs, and then the other piece was the neurotransmitter. When we look at the somatic nervous system, that neurotransmitter being released is acetylcholine. It always turns on that skeletal muscle. In the sympathetic division and parasympathetic division, the first neuron in the pathway, so that preganglionic, presynaptic neuron, is releasing acetylcholine onto the second neuron to turn it on. Now that second neuron, the second neurons are going to be talking to the same thing, so we need to make sure that those effector organs know, hey, there's more norepinephrine, or there's more acetylcholine, who's in charge here? And so norepinephrine is coming from the postganglionic sympathetic neuron here, and we see acetylcholine is coming from the postganglionic parasympathetic neuron here. I said ignore this for a minute, but now we're going to come back to it, and this should sound very familiar. The same cells, which are those neurocrest cells that came out of the lateral folds that when we were creating the neural tube, those neurocrest cells are going to migrate around the body and create a lot of different things, including the ganglia of the autonomic nervous system. Well, the same cells, those neurocrest cells that created the ganglia, also end up in the middle of the adrenal gland, in the adrenal medulla, and create cells. Anybody remember the name of those cells there? Chromaffin cells. The only difference is these chromaffin cells never develop an axon, but they still make norepinephrine. They still make norepinephrine just like the sympathetic ganglion, postganglionic cells do. So the cells, the chromaffin cells, are basically coming from the same population that created the postganglionic neuron in the sympathetic division. It's just they never grew an axon. And so releasing a norepinephrine as a neurotransmitter is not what they do. Instead, they release it as a hormone, and it stays in the system much longer. And that ends up, if you've been scared, and if something happens and triggers your autonomic nervous system, your sympathetic division, you kind of feel tuned up or kind of tweaked for a couple of days afterwards, and that's because what's happened is we've also released norepinephrine and epinephrine into the bloodstream, and it's going to keep the division, that sympathetic division, ready to kick in and have a higher response because of that hormone that's floating around within the system and binding to cells that have receptors for the norepinephrine and epinephrine. Okay? So when that bear jumps out in front of you, not only are you sending more information down this 2-neuron pathway to these effector organs, but you're also sending information to those chromaffin cells that release norepinephrine and epinephrine into the bloodstream, which is going to impact cells around the body, anybody that has a receptor for the epinephrine and norepinephrine. If you didn't like that chart, this thing does the exact same thing. So here's your somatic nervous system, here's your autonomic nervous system, this is going to be your sympathetic, this is your parasympathetic, and here's your chromaffin cell pathway. And if you're more of a chart person, this does the exact same thing as well. The only problem is the editors missed the fact that this should have been over here, and this should have been over here, but you can see here's the input control, here's the motor pathway, the neurotransmitters, what are the effectors that are being used, and the different responses that we can get. Yep.
So for the slide, like previous.
Yep.
When it says like the autonomic ganglion, like where exactly is that? Is it somewhere like floating in the body?
So the autonomic ganglion, it depends if it's sympathetic or parasympathetic. If it's a sympathetic ganglion, it's typically near the vertebral column. So it's either going to be next to the vertebral column or in front of the vertebral column. If it's parasympathetic, it's actually further out. It's actually going to be in the wall, near or in the wall, the organ's being innervated. So do you remember when we looked at the GI tract and we saw the myenteric plexus and Arbox plexus? Those are actually parasympathetic ganglia. Yeah.
I had a question about that because I've always wondered why it's beneficial for the preganglionic fibers of the sympathetic nervous system to be closer to the spinal cord.
I don't know what the benefit is. It's just the way that it's laid out. So some reason during embryonic development it developed that way. Now the interesting thing is, and we'll talk about it, is that the first neuron in the sympathetic division pathway is myelinated, the second one's not. And you would think that if you or a bear jumps out in front of you, you want that information to go where it's going as quick as possible. But it turns out the second neuron in the pathway is not myelinated. So why that is, I don't know. Any other questions? Okay. So let's talk about these two divisions a little bit more. So we have the autonomic nervous system, we have the parasympathetic division and the sympathetic division. And most of our cardiac muscle, most of our smooth muscle, most of our glands is going to get this dual innervation from this. One will cause inhibition of that smooth muscle, cardiac muscle, or gland. The other one will excite it, will turn it on. And so we get this dual innervation, so we get very fine control of the smooth muscle, cardiac muscle, and glands. We also know that with the autonomic nervous system, with these two divisions, the parasympathetic division is your rest and digesting system. It does your maintenance and housekeeping activities, does a lot to help conserve body energy. So things like actively controlling active digestion, elimination of urine and feces has caused the pupils to constrict. So we're going to protect the retina, but it also is going to allow for the eye to focus on something that's up close. We're going to lower heart rate down to normal rates. We're going to lower respiration rates. While the sympathetic division, the autonomic nervous system, is your fight or flight division, and we're going to see that this is going to mobilize the body during extreme situations. You're excited, scared, threatened. When you're in an emergency situation, you can feel that heart rate starting to increase. You can see that respiration is deeper and it's going to have and be more often. You start to sweat. You're going to dilate the pupil, so you let as much information in about what's going on as possible. You also accommodate the lens for further away vision and along those lines. So these are just some things that these systems are going to impact. Well, when we look at these two divisions, we can see that there's differences in things like site of origination, the length of the axons, and where the ganglia are located. And we've talked a little bit about this already. In terms of sites of origin, the parasympathetic division, the autonomic nervous system, is also known as the craniosacral division because it's going to be coming from the brain, specifically from the brainstem, and the sacral portion of the spinal cord, the portion of the spinal cord that gives you spinal nerves S2, 3, 4. So somewhere in the brainstem, somewhere in S2, 3, 4 is going to be the cell body of the first neuron in the pathway for the parasympathetic division. So we're going to see that first neuron having its cell body in the brain, specifically the brainstem, or the sacral portion of the spinal cord. The sympathetic division, the autonomic nervous system, is also known as the thoracolumbar division. Because remember when we looked at the spinal cord cross-section, they said ignore that yellow for right now. We're going to add that back in. Because in the thoracolumbar division, or region, so from T1 to L2, not only do you have anterior horns, not only do you have posterior horns, but now you have a third set of horns, and they're called lateral horns. And in the lateral horns are the cell body of the first neuron in the pathway. So that preganglionic sympathetic neuron has its cell body in the lateral horns. Okay? What about the relative length of fibers? So what about the axons? Parasympathetic division of the autonomic nervous system. Okay, it's going to have its cell body in the brainstem or a little extra gray matter along the sides. It's not enough to make horns on the S2, 3, 4 region of the spinal cord. And what we're going to see is that the first neuron in the pathway, that preganglionic parasympathetic neuron, is going to have a really long axon. So it's going to go out really far, almost to what's actually being innervated. And as we talked about, that's where we find the ganglia right next to or in the wall of what's being innervated. First neuron synapses with second neuron. Second neuron goes, hey, there's that smooth muscle, cardiac muscle, or gland right there. And just sends a little tiny axon over. So the second axon in the pathway is relatively short. It's the opposite for the sympathetic division of the autonomic nervous system. So from T1 to L2 in the lateral horns are the cell bodies of our preganglionic sympathetic neurons. They're going to send their axon out, but it doesn't go very far, because right around the vertebral column are sympathetic ganglia. First neuron synapses with second neuron. Now the second neuron, that postganglionic sympathetic neuron, is going to send its axon all the way out to that cardiac muscle, smooth muscle, or gland. So it's much longer. Well, that also means where the ganglia are located is different between the two systems as well, and we've talked about this already. If we're talking about the parasympathetic division of the autonomic nervous system, craniosacral division, we're looking at either in the brainstem or in the S2, 3, 4 region, just a little extra gray matter along the side, not enough to make a horn. Horns are only found with the sympathetic division. There are cell bodies for preganglionic parasympathetic division. They send out their axon, and it's relatively long axon. And it goes almost all the way to what's being innervated, and right next to, or actually in the wall of what's being innervated, are the parasympathetic ganglia. First neuron synapses, the second one sends that little short axon over. So that means the ganglia for the parasympathetic division are in or near the effector organ being innervated. Sympathetic division is the opposite. Remember thoracolumbar division. In there are the lateral horns, where the cell bodies of the first neuron are located. They're going to send their axons out, but they don't go very far before they run into the sympathetic ganglia. Sympathetic ganglia is where you find the cell bodies of the postganglionic sympathetic neuron. First neuron synapses with a second neuron goes the rest of the way out, all the way out to that effector organ. Okay? Mm-hmm.
I just want to clarify, the lateral horns, they're where the cell body is located, preganglionic neurons, is that for the sympathetic, para, or both?
Just sympathetic. So remember when we looked at this picture here, I said for right now ignore the yellow. When we were in the last unit, we're adding that back in. So in from T1 to L2, there are lateral horns. So you have anterior horns, posterior horns, and lateral horns. Everywhere else, there's no lateral horns. Now in the S2, 3, 4, you do have some sympathetic information, parasympathetic information coming out, but it's very little. So it's a little extra gray matter, but not enough to make a full horn, so they don't call those horns in S2, 3, 4. So you do have parasympathetic information coming from the spinal cord, but it's not enough to make a horn. So if you guys are using the textbook on this chapter is not real great. I'm working on fixing that right now. And so what I just said, everything I just kind of walked out here is right here, okay? So all this information is basically typed out here. Just to add a little bit more to it, the cell bodies of the preganglionic neurons, the parasympathetic division of the autonomic nervous system, remember, are in the brainstem. And remember those cranial nerves I said carry parasympathetic information? 3, 7, 9, and 10. Well, that means that 3, 7, 9, and 10 are carrying that parasympathetic information away from that brainstem. They're the ones that carry that information away from it. but you also get a little bit out of the sacral portion of the spinal cord, the portion that gives you S2, 3, 4 spinal nerves. Not enough to make a horn though, just a little bit extra on the side. So we get the craniosacral division. First neuron, which is preganglionic, synapses with second neuron, and it's going to do that far away from the central nervous system, in the wall, sometimes even of what's being innervated. So the first neuron is relatively long axon. The second neuron is going to have a relatively short axon, and the two are going to synapse in a ganglion, which is going to be at or near what's being innervated. Then with the sympathetic division, cell bodies, the preganglionic neurons in the sympathetic division are found in the lateral horns of T1 to L2, the only place you ever find lateral horns. That's why you also call it the thoracolumbar division. We see the first neuron synapsing with the second neuron right near the central nervous system. Well, if it's coming from T1 to L2, that means we're going to have our ganglia near the vertebral column, either right next to or in front of the vertebral column, that are sympathetic. That means that the first axon in the system will be relatively short. The second axon will be relatively long, heading out to where we're going. But where we're going, and these are two different, completely separate charts, and the reason they're on here is to show you that they're going the same places. So here is the output from the parasympathetic division, craniosacral output. And what we're seeing is that here over here is going to be the output from the sympathetic division. Where you're going is almost exactly the same. It's just how we're getting there is a little bit different. And we want to get that dual innervation to that smooth muscle, that cardiac muscle and those glands, so we get very fine control of that smooth muscle, cardiac muscle, and glands. When we look, parasympathetic division, craniosacral origination, we're going to see that has a relatively long first axon. Second axon is relatively short, and the ganglia, where the cell bodies of the second neuron are located, right next to or even in the wall of what's being innervated. Sympathetic division is complete opposite. We're going to see that the first neuron, which is coming from T1 to L2 in the lateral horn, will come out, and there's going to be ganglia right next to the vertebral column, where first neuron synapses the second one, and the second one's going to be much longer, heading all the way out to what's being innervated. If you're more of a chart person, this tells you the exact same thing as well. So you can see the characteristics here. Here's the parasympathetic, and here's the sympathetic division, the autonomic nervous system. Anybody have any questions? Take a break. Stand up for a minute. No, keep going? Okay. Keep going. So let's break it down just a little bit more. Now, ask you if you want to break it about 5 minutes after this one. Okay, so let's break it down a little bit more and talk about the parasympathetic division, the autonomic nervous system. Parasympathetic division, okay, this is giving you a rest and digestive system. This is going to be where we have the cell bodies of the preganglionic or presynaptic parasympathetic neurons are located in the brainstem, or in that little bit of extra gray matter in the S2, 3, 4 region of the spinal cord. So we're coming either from the brainstem or that little bit of extra gray matter down here in the S2, 3, 4 region. Because of that, it's known as craniosacral in origination. And we're going to see that the first neuron is going to go out almost all the way to what's being innervated, sometimes even in the wall of what's being innervated. The parasympathetic ganglia are known as terminal ganglia. So when they go the first neuron goes all the way out, it's going to get to what's known as a terminal ganglia. So all the parasympathetic ganglia are known as terminal ganglia. These terminal ganglia sometimes have a specific name, and they'll have a specific name when they're associated with the parasympathetic information coming from 3, 7, and 9. Or remember when we were looking at things like the GI tract, those ganglia that are actually in the walls of the organs being innervated are hard to say they're always sitting in the same spot. I mean, yeah, they're sitting in the same spot within the wall layers, but maybe it's a little bit more dorsal, maybe it's a little bit more ventral, maybe it's more superior, inferior within the tract system. And so if it's in the wall, the terminal ganglia are just known as intramural ganglia. So terminal ganglia can have a specific name, or terminal ganglion, or just known as the intramural, if it's in the wall of an organ being innervated. So let's talk about how we're getting this information out. We know that the parasympathetic division of the autonomic nervous system is craniosacral, and we know that if it's coming from the brain, it's coming from the brainstem, and the axons of our preganglionic parasympathetic division are going to come out and travel within cranial nerves 3, 7, 9, and 10. So the question is, where is that parasympathetic information going? If it's traveling with cranial nerve number 3, we're going to see that cranial nerve number 3 is carrying that parasympathetic information. And you don't need to know the names of these specific ganglia. Just remember these terminal ganglia have very specific names. You'll learn them at some point. And we see that this information comes over to the ciliary ganglion. First neuron synapses with second neuron. Where's that second neuron going? Where's that parasympathetic information going? Well, it goes to all of that smooth muscle in the eyes. So it's changing the size of the pupil. It's accommodating the lens for close vision. Okay. What about the information, the parasympathetic information that's traveling in the facial nerves? Well, the facial nerves, that parasympathetic information comes out the brain, out of the brainstem, travels in cranial nerve number 7. You can see right here, ends up at the pterygopalatine ganglion, ends up the submandibular ganglion. But where is that information going to end up in the end? Well, what's traveling with cranial nerve number 7 is going to end up going to the nasal, lacrimal, submandibular, and sublingual glands to activate them. But what about the parasympathetic information traveling with the glossopharyngeal nerve? So we see the glossopharyngeal nerve coming off the brainstem. And we're going to see that glossopharyngeal nerve is going to travel along for a little bit. It's going to end up at the otic ganglion. First neuron synapse with second neuron. Second neuron doesn't have to go very far, and where it ends up is controlling the parotid gland and going to be activating that parotid gland. Okay? That's parasympathetic. So a lot of these glands are utilized for things like digestive system. Well, that's 3, 7, and 9. What about 10? Well, cranial nerve pair 10, remember we said is predominantly parasympathetic. So when we look at the vagus nerves, yeah, we get a little bit of muscle, we get a little bit of sensation in the neck region and things like that. But most of the axons of the vagus nerves are preganglionic parasympathetic axons that are going to leave the head and neck region. So they're going to leave the head and neck region, and they're going to come down, and they're going to turn, and they're going to follow the esophagus down into the abdomen. Now, as they're traveling through the thorax, they're going to give off some of their axons to control things like the lungs and control the heart and so forth. But the rest of those vagus nerves will follow the esophagus down into the abdomen. And these axons, these preganglionic sympathetic axons, will synapse in terminal ganglion known as intramural ganglion with the cell bodies, the postganglionic parasympathetic neurons. So the vagus nerve ends up at terminal ganglia that don't have specific names. They're just called intramural ones because they're in the wall of the organ being innervated. These postganglionic parasympathetic fibers innervate things like the heart, lungs, liver, gallbladder, stomach, small intestine, pancreas, and the proximal 1/2 of the large intestine. So remember the large intestine? We started with the cecum. We went through the ascending colon and then the transverse colon, and then the descending colon and so forth. Right over here near the spleen, this is known as the splenic flexure, where it turns and heads inferior. Near the splenic flexure is where the vagus nerve stops its innervation. It's about 2/3 of the way across the transverse colon. So about 2/3 of the way across the transverse colon, near that splenic flexure, we're going to see the ending of the vagus nerve's innervation of the GI tract. Okay? But if you think about that those 2 vagus nerves are hugely important because they're providing parasympathetic fibers to almost every organ in the thorax and abdominal cavities. But not everything, because we still have the rest of the GI tract, the descending colon, the last 1/3 of the transverse colon, the descending colon, the sigmoid colon, the rectum. We still have the pelvic organs. and that's what's coming from S234. So from S234, we're gonna see that along the sides, there's a little bit extra gray matter. And in there are preganglionic parasympathetic neurons. Well, this is motor information. And if it's motor information, how do you think it gets away from the spinal cord? Does it take the ventral root or dorsal root?
Ventral.
It's gonna take the ventral root. So we're gonna take the ventral root, we're gonna get into the spinal nerves, get into the ventral rami, because the ventral rami are heading towards the front, and then they jump off as wandering nerves. Splanchnic refers to wandering. Wandering nerves, they're called pelvic splanchnic nerves. Starts with a P, parasympathetic. So these are preganglionic parasympathetic axons that are going to start traveling towards what they're going to innervate. Once they get into the walls of what they're innervating, they're going to then synapse in intramural ganglia with the postganglionic parasympathetic neurons. They then send their little tiny axon over and get the rest of the large intestine, so the last 1/3 of the transverse colon, the descending colon, the sigmoid colon, rectum, urinary bladder, ureters, reproductive organs, and so forth. So here's our cranial output. Here's our sacral output. Here are all of our terminal ganglia with specific names. Those are associated with 3, 7, and 9. 10 is going to go to intramural ganglia as well as the pelvic splanchnics. You can see the output there. Questions? Break? Yeah, we're getting a little bit of, getting that glossy look. Why don't you guys take 5 minutes, stand up, stretch, we'll come back and talk about how we get